Hi there, Phil. How's it going?
Oh my gosh. Hey,
Hello.
you are now a co-host. And nice to meet you, Reilly.
Yeah. First time in person.
Okay, good. It's recording too. I'm dealing with lots of last-minute people emailing me, so.
Did you have a lot of trouble with spammers or something? Or?
Yeah, you can see them in some of the other recordings. One time someone came in and started like blaring music. One time, yeah, just stuff like that. There have been a couple of Zoom controls that I've learned about since, but I'm still. And the annoying thing is, like, their webinar, well, there are different things. They have this webinar system where there's only a couple of people presenting and there's no worry about anyone. But that's not even in their like lowest tier. And I think I'm paying like $40 a month or something for this. So it's even on top of that.
Yeah, that sucks.
But also, when you have the webinar, you can't have any interactions, or like you can only have interactions through chat. And it has been nice the times that we've had people, you know, we just talk at the end. I thought that there was only going to be like, I was prepared for like 5 people to respond when I said that you'd have to message me, but it's been, I'm surprised how many people have gone through the effort. I'm gonna wait till like 8:05-ish.
So Phil, when did you start doing this meetup?
Sometime earlier this year. I think this is the 4th one. I wish.
Guess it has always.
Sorry.
I guess it has always been remote.
Yeah, yeah.
Not in person. Yeah.
And hey, there you are. And is it Julio or Julio or something else?
Julio.
Julio. Awesome.
Yeah. Nice to meet you all.
Yeah. Nice to meet you. Yeah, I wish Meetup.com had better like discovery for totally online meetups. A lot of people, I send them this and I'm like, hey, you should come. And they're like, but I'm not in New York. I'm like, well, it's not in New York. All right, it's 8:05. Giving everyone 5 minutes. More may still show up, but yeah, let's get started. Hey everyone, thanks for coming back to the 4th or 5th or whatever one of these is. Nice to see so many familiar faces. Just a reminder, as usual, this is being recorded right now, and afterward it'll be put on YouTube. The link will be shared in Discord. Hopefully you can see the screen. Discord.multicross.l. It'll also be shared on the Meetup page, and I'll post on Twitter. If you feel like it, you can go to chat in the Discord channel here on the HackerNights channel, especially since the chats don't really get preserved in Zoom. Yeah, that's it for the announcements. The format is like 10-15 minutes for each speaker, and then 5-10 minutes for questions after that. If the speakers want to allow questions during the talk, that's fine too. I'll give you each of you speakers a heads up when you're a minute or two away. And Reilly, I think you're up first, so take it away.
Cool, sounds good. Let me just share my screen quick. Okay, is that showing up for people?
Yep.
Cool. Okay, so yeah, let's get started. My name is Reilly, and for some reason the keyboard shortcut to start PowerPoint is not working. Okay, there we go. Hi, so my name's Reilly. I'm a programmer in Vancouver, Canada. I work on a project called Nushell, and today I'm going to give a quick overview of it and a demo. So Nushell's a command line shell, kind of like Bash or Fish or PowerShell. It's also a programming language, very much like you can write scripts in Bash. You can also write scripts in Nushell. We think Nushell is a better scripting language, but I'll get into why later. And it's an open source project. We've got nearly 20,000 stars on GitHub. It's written in Rust, and it was started about 3 years ago by a person named JT. JT is a pretty interesting person. Used to be in charge of TypeScript at Microsoft and is currently on the core team for Rust. So that's actually a big part of why I joined Nushell, is to learn from JT. Super interesting person to talk to. And you might wonder why we are building a new command line shell, given that there's lots of existing ones already out there. And there's a few reasons. So I think the biggest problem with a lot of existing command line shells is that they are mostly text. So if you use a traditional POSIX shell like Bash, really the only structure there is like line breaks in between strings of text. And so you end up doing a lot of string parsing just to solve very common problems. And the second problem is that there's a real divide between shell scripting and real programming. Sort of the common wisdom is that as soon as your shell script starts getting complicated, you should move it to a real programming language. And we think that's kind of unfortunate, and we want to sort of raise the ceiling of what you can do in a shell scripting language. And finally, the cross-platform story for a lot of existing shells is not great. Like Bash and ZSH and all of those are very much come from a Unix background, and they're not great if you want to use them on Windows. Vice versa, PowerShell, you can technically run it on Linux and Mac, but you're not always going to have the best time. So Nushell was sort of designed from the ground up to be usable on all 3 major operating systems, and we take cross-platform support pretty seriously. So let's just dive into a demo, because I think that's the best way to explain Nushell. So I've got Nushell open here in Windows Terminal. And if we type ls, we can get a list of files. And right away, you see that it's an actual table. There are columns and rows. And if we want to sort of project it, like maybe get one of those columns out, that's pretty easy. We can sort of pipe the output of the ls command to this other command called get, which just gets a single column. So super easy to get bits of the data like that. And if we wanted to slice it another way, like maybe we want to filter out rows, we could write a where command like this, where we only get the files that are larger than 100 kilobytes. So that's ls. We can also do similar things with other types of data. So if we run ps, we get a list of all the processes running on my machine. And then we can start doing similar things like, hey, show me all the processes that take up more than 200 megabytes. And one kind of cool thing about this is, let's say we take the MB off the end of that. We'll actually get a type error, because Nushell is working on structured data. Each of those columns has a type. And if you try to treat like a file size value like it's an integer or vice versa, Nushell is smart enough to say, hey, you're doing something wrong here. I'm not going to let you. And I find that sort of type safety is really helpful for writing reliable shell scripts. And let's see what else. So we're working with processes. We could also maybe sort them by memory usage. So that would be a quick way to sort of get an overview of what your memory hogs are. We could take that a bit further, add a reverse flag to that sort, and then only grab the first 10. And then boom, we've got like a pretty succinct pipeline that shows the top 10 memory hogs on my system. So I build up little pipelines of commands like that pretty often when I'm working in new. And one of the things I want to highlight is that we're working with all of the same sort of data slicing and filtering and sorting commands, no matter where our data comes from. So like whether we're looking at files or processes, we can use the same commands to work with the data. And we can actually take that a fair bit further as well. So we could also import data from other files. Like I've got a file called cargo.toml in this directory. And that is just sort of like a toml file that I copied over from our Nushell project. It looks like this. It's just a standard toml file. And because Nushell speaks toml, we can do something like this, where we just tell Nushell to open the file, parse it, and then return it as a Nushell record or a table. And then, we could just start drilling down into it pretty much the same way as before, get like a package property out of that. And if we wanted to, we could use the dot operator to drill down even further and get the version property. So super useful if you're dealing with like, lots of files and you want to extract one piece of data out of multiple files. And that works for TOML, but it also works for JSON and CSV and even Excel files. And it also works for some file formats that you might not expect. So I've got this file here called chinook.db, and that is a SQLite database, just for a sample application I found online, kind of like an iTunes clone. And if you just open it, Nushell is able to detect that it's SQLite and load it accordingly. So that's a list of all the tables in the database. And then if we want to get the contents of one particular table, we could do that. But if Nushell's like sort of built-in query commands don't work for you, you could also sort of fall back on a more domain-specific language. In this case, the language of databases or relational databases is SQL, and you can actually write SQL against SQLite databases. So we could use this sequence of commands and then give it sort of a raw string at the end of SQL that we want executed against the database. And then we get back a Nushell table from that. So that's pretty powerful. But you actually don't have to work only with files on your local system. So we can also bring in data from, say, REST APIs. We've got this command called fetch, which will make an HTTP GET request and then like sort of try to parse what it gets back. So if the API responds with JSON, it'll parse that. So we could use it like this to sort of query GitHub's API. I use this kind of thing pretty often to just act as like a Postman replacement. And it's pretty useful for that sort of thing. So yeah, that's kind of all the ways you might work with data in Nushell, but it's also a programming language, and I want to show you a little bit of that. So you can define variables kind of like how you would expect. You just use the let keyword, and then if you want to reference them, you can use $. And then you can also define custom commands as well, super quickly. So use this syntax with def, and then we've got the command name hello. We've got an argument called name. We could give that name a type if we wanted to, but we don't have to. And then we go and do something with that name. We print it out. So if I define that, then calling that custom command is as simple as just giving the command name and then a space and then an argument. And yeah, so that's sort of like custom commands that you would define on the fly. But if you want to move those into scripts, that's pretty easy to do as well. I've got something pretty similar in this hello.new file. And if I wanted to run that, I could run it like this, and it'll just say, hello, HackerNights. But yeah, that's kind of a whirlwind tour. There's obviously a lot more to the programming side of New. It's sort of a functional language. Generally, we don't allow mutation, but you can shadow variables and things like that. Yeah, you can actually do quite a bit with it. And finally, I want to show you one more thing, which is sort of where we're going with New. Something that we're experimenting a lot with. So lately, we've been hacking on this thing called Nana, which is essentially a GUI for Nushell. And it's basically like a web UI strapped to Nushell's Rust backend. And you can run sort of the same commands you would in normal Nushell. They show up in this like sort of card UI. But you can also do a few things that you can't actually do in a terminal or can't easily do in a terminal. So for example, if you want to, you can display images in the terminal. And we're working on some features where you can also like sort of click into the file system and interact with it in sort of non-typing ways. We're working on this partially because it enables new things like displaying images and all that, but also because we think it's going to open up Nushell to a lot of people who might not be comfortable with the terminal. And yeah, that's kind of it. So If you want to learn more about Nushell, these are the links. I'm always happy to chat, and other people on the core team are as well. Yeah, happy to take any questions that anybody has.
This is incredible.
Thank you.
As you were going through it, yeah, I've seen Nushell a couple of times, and it somehow didn't really click like this before. It felt like you're just treating the entire system kind of like a database, because you can basically query everything, at least read-only query.
Yeah, definitely. I would say that updating things is maybe not Nushell's strong suit right now, but yeah, for querying, we're fairly happy with where we are.
So how does that work? Do you have to open all these kinds of files that you support? Is that built into the shell, or you have plugins, or how is that?
Oh, it's a good question. Both. So we have a lot of built-in commands. We ship with quite a few built-in file formats, but we also have a pretty extensible plugin system. Basically, the plugins Nushell plugins are just executables. Like Nushell launches them and then communicates with them over standard in and standard out, just over JSON. You can write them in any language you want.
How would you compare this to PowerShell, for example?
How do I compare it to PowerShell?
Yeah.
It's definitely inspired by PowerShell. Like, PowerShell does the same sort of structured data thing that we think is really important to shells. It's different in a few ways. The first is, better cross-platform support. It starts up super quickly, unlike PowerShell, which is very slow to start up. And much less verbose. I just can't really get into PowerShell. I don't like the syntax. I don't like that it's very, very much Windows first. I think it pioneered a lot of cool stuff, but I don't personally like it. I enjoy using Nushell, and that's why I got started working on it.
Can you run SQL queries against, can anything that you pipe in and get a table from, that you process through Nushell, can you run a SQL query against it, or was that only demonstrating SQLite?
That is only for SQLite right now. Yeah, we literally just send the SQL along to the SQLite library and tell it to run it. Yeah, it might be interesting to think about. Yeah, we ship a copy of SQLite with it. Yeah.
And that is, sorry, that was just, that's only for running SQLite against existing SQLite files.
Correct. Yeah. For now.
Your microphone may not be working.
Oh, okay. Not working?
Yes.
Test.
Yours is
test.
Yours is fine. Sorry. Or if you want to type it in chat, if you have a question there, I can.
Yeah, what else? No, oh, that's an interesting question. Not really. You could, launch Nushell and tell it to run one command and then get the results back. But it's not really a use case we've looked at or tried to cater to. It's interesting to think about, though. I could maybe talk. Go ahead.
No, so that's a simple question. Like, how big would you say the project is? Number of developers, users, lines of code?
So, how big?
Yeah.
That's a good question. I should really know that. It is fairly large, but also we depend on a lot of external packages. Like, one of the nice things about Rust is that the package manager is pretty good and the ecosystem of packages out there is pretty good. Nushell is fairly ambitious. Like, we don't want to write our own JSON parser, our own Excel parser, like all of those things. We rely on crates for a lot of stuff. And so I don't have exact numbers for you, but I would say that we rely on, I think, like 400 other packages to build Nushell.
But when it comes to interpretation, how does your interpreter work? Is this an AST interpreter? Do you have an internal like bytecode VM? How does execution work?
We build up an AST and then, yeah, and then interpret it. I don't work on that part of it too much, but yeah, we're not doing a bytecode interpreter or anything like that yet.
Well, that's a great transition into the next talk, which so Julio, do you want to tell us about some cool interpreters?
Sure. So hi, my name is Julio. I work at Microsoft now. I use PowerShell because I have to, but I don't really like it either. I just asked because I've been trying to learn recently. I was making Ruby for a while. I was in New York actually, but I moved to the West Coast during the pandemic.
Sorry, Julio, I'm having a little bit of trouble hearing you. I don't know if anyone else is, but if you could turn your mic up, that might help. Sorry.
I might be using the wrong microphone. One second. Can you hear me now?
Yeah.
Better?
I think so.
Okay, I'll try. So I wanted to talk to you about this project that's called EndBASIC, which is a basic implementation that I started writing during the pandemic. Part of the reason why I started, I have good memories of when I learned how to code, right? And I have a couple of kids, and I would like to teach them how to code. But all the current environments seem very complicated. Right? You have all these compiler on one side, you have an editor on the other side, and the IDE is very complicated. So I thought maybe something like in the past would be nice. So let's see if I can share. So this, I don't know if you can see it, a blue window, is how I learned how to code. Right? In a computer like this, you would turn it on, and in a couple of seconds, you would have this running, and right away, you could easily type commands there and get that output. Right? And you could do things like, is this how it works? Say set colors, I don't know, clear the screen, right? And it was very immediate. You could type commands and get something visual very quickly. And as soon as you learn something, you could write a program, right? And do whatever it is. And then just run it. And it would be there, you would save it. And if you messed up, you press the reboot button and it will be ready back with you in a couple of seconds. Right? So I wanted something similar, and I started prototyping something in Python, a tiny library you could probably import from the command line and use it. But I wasn't happy with that. It's like, how hard can it be? I mean, the language is dead. Obviously, but so that's what brought me to write this this thing, which I'm going to show you now. So here I have, EndBASIC, which is again this interpreter rewriting. It's also written in Rust, everything. So I'll show you later. There are some parts that are not, but the vast majority of the project is Rust. And I started writing this on the console, right? And here you can do the same thing as you were seeing before. You can change colors, clear the screen, and help and everything that's there. And you can enter the program like you were doing before, right? Then print next the built-in editor, and then you set your exit. The program is set in memory, and you can just run it like kind of like we were doing before. This is all integrated, right? This program is not in memory. We can go back to it, edit, modify it to do something else, and you run it. That's what it should be doing. Then obviously we have support for saving it, right? It will be saved in something called the local drive, and we can see what's there. We can load something different, right? See what's there, run this stuff, etc. This piping is just a little program I wrote to help my daughter learn the pi number for school. But anyway, so it works, right? And we have features again for the file system. Like we have a file, and you get information on how drives work, what you can do with them, where you are, and what was it? There are functions for managing numbers, strings, arrays. It's not very complete yet, but the foundations are there. And if you want to learn how the language works, we type lang, and then you get the basics of how the language looks like. So that was kind of the beginning. It's more or less how it looked like a couple of years ago. Obviously, it's more complete, but there are a few features that built after that were, I think, key differentiators. So the main one was that as soon as I showed this to my kids, it's like, well, but they have an iPad, and I kind of want to use an iPad, right? And I wanted them to play with it there. And I thought, well, Rust has this WebAssembly target, so maybe I can port the project to WebAssembly, and that's what I did. So we can go now to the web, right? You see the browser now?
Yep.
Yeah. I'm not getting the yellow border. I don't know why. But okay, so now here we have the EndBASIC website. You can go there if you would like. But the key thing is like we click launch interpreter, and we get the same thing we had in the terminal, but now it's running in the browser. It's exactly the same thing, right? We can operate in the same way as before, and the colors are a bit off, but it's exactly the same. Except here is where the I think the cooler thing comes in, which is graphics, right? Part of what I didn't show you before from the emulator is that that machine had the ability to draw graphics very easily in the terminal. And for a little kid, I think that was really exciting to have immediate output. So here we can do the same thing. We have graphics, and let's see different colors. Pick, for example, you can do a rectangle from 100 to 100, and there you go. And it's right there. And you can do the same thing. Let's make it bigger to see it's kind of overlapping with the console. It's kind of intermediate thing between graphics and text and all mixed up. And that lets you play with graphics very easily and start practicing, things you can do together with them. So things you can do, we can, do I have it here? No. So yes, so my drive is empty, but now we have graphics, right? And that's one thing I have to show you. The other is this drive that I show you here is for local, and it is backed by the browser's local storage. So everything I save here is saved on my machine. There is nothing shared anywhere else. But I can do this. I can log into my cloud account that I built for this stuff as well. Hopefully it works. And when I'm there, now if I touch mount, we have a new drive called cloud. So I can go into cloud. Now I'm in the cloud drive. And I can see other stuff that is there. And that stuff is readily available for other people to just look into, right? And I can, for example, load a sample program, run it, and that's graphics right there in the browser coding on this stuff. You can edit and see how the code looks like, modify it, and blah, blah, blah. Okay, so what else do I want to show you? So we have the cloud drive. Something else I was working on recently is the ability to share files publicly. So you have your drive. The whole idea was to be able to share stuff. So, for example, if I go to the gallery on the website, we have these links here, which are just like, let me copy this, for example, copy link. Here we can see the same site as the interpreter as before, but with this parameter to run this pay.bas file from my personal account. So we just run this. We automatically go into this interpreter with the program loaded, and we can interact with it, play, whatever. And then once this is running, and once we exit, we are dropped into the interpreter. The code is still loaded. We can inspect it if we want. We can edit it. We can save it again in our drive and show it if you would like to. Yeah. And the last thing, I think I'll show you this now because I don't have my Raspberry Pi with me. But there is also some support for hardware. If you build this for Linux, you can manipulate GPIO in a very rudimentary fashion, but I was able to control some LEDs and buttons and stuff. So I have a little. The whole goal of this was to be able to write some games, right? So that's why I want to have graphics and some kind of input and sound, which I'm still missing, but it's almost there. So yeah, then I didn't prepare this very much because I wanted to improvise a little bit. If you want something that's more like well prepared to learn more about this, what's this demo I made last year? It's 5 minutes long. It kind of covers what I did now in a more structured manner. And yeah, there's this page for documentation now. It's a very recent edition trying to explain how to navigate this thing. The program tries to be very self-explanatory, but there are many things that I'm not obvious about. I captured them here. And before you ask, does everyone tries the same thing? Go-to is not supported. I have to do this. I haven't had the chance to do it yet. So it's still a bit of a problem to write any code that's more than 100 lines long, I would say, because you don't have support for functions or anything. I mean, there are functions you can call, but they're all built in. Right, you kind of define your own and you kind of jump. So it's very convoluted to write something that's more than a few lines. But that's the next thing I want to do for the next release when I have a chance. That and some mechanism to play sound, and that will be more or less feature complete. Yeah, I think that's all. You can also go to GitHub. All the code is there. I've tried to break it down into very small crates. Like the core crate is where the language is, and if you build that, for now it's like I think it's 500 kilobytes only, which for these days is very small. You know, it's huge for the machine I showed before, but it's pretty small, and you can iterate it with your own programs if you want. And there is the STD library functions, right, and then other cryptic stuff. But yeah, that's more or less all I had to cover. I'm happy to take questions or show more stuff if you're interested.
So my big question that I've been talking with you for a while about, so can you tell us about how the interpreter works under the hood and why GoTo has been a challenge and what your planned solution for that is?
So the interpreter is just now an AST. It just builds an AST, and it iterates over it and runs it. GoTo has been a challenge because I didn't want to add it at first, right? I wanted to have ifs and loops pretty much in functions later. So it wasn't part of my original plans. Now retrofitting it, it's a problem because jumping in the AST is complicated. There's also the question, right, if you start having GoTo with line numbers, which is what the original BASIC had, is that what do you do? You jump in the middle of a loop, in the middle of a if statement or something. So there are a lot of decisions that need to be made there. I would like to bring back line numbers into it, so it's more like retro looking, but I have doubts about that because it's not what I like, you know, in the sense for the language. So maybe a compromise I would have like quick basic tasks, like you have labels and jump to label. And then for that, I can probably hack my way around unwinding the call stack in the AST to find the right label and then jumping to it. But that seems like a hack, so it would be really cool to write some kind of bytecode or flatten the AST, you know, so that I can actually jump to the right places and expose that in some way to the user so you can inspect the memory of the machine. So that would be super cool as well. For now, I think I'm just going to extend first the language to have main functions, right? So you can just call them in the same way you call anything else. The support for that is there already. There is this trait to implement commands, which are the procedures basically and functions with return values, and hook into that to expose customly defined functions. but I still would like to have some form of code. And that's where it should be within the function. And if you look at, for example, how quick BASIC evolves, I was trying to look into it, and GoTo is much more restricted than it was, for example, BASIC, legitimately BASIC, for example. Probably because it's a more structured language, so you can't have GoTo going anywhere. Well, you can, but I don't really want to have that. So yeah, I just need time for it. And now I'm kind of distracted with another project I wanted to work on for a little bit. And I have something else in my queue that I would like to get started. So it's hard to juggle everything on the side. Any more thoughts on this? I know you know a lot of these topics. I'm happy to hear your thoughts.
No, I'm just excited for whichever one you pick for solving that, because either way, it's gonna be fun.
Any other question?
Yeah, I've got a question. Have you had any beginner programmers use this yet? Like, has anybody learned programming using EndBASIC yet?
Not that I know of. I had a couple of people reach out to me saying, "Oh, I showed this to my kids, and they were super excited and they liked it," but I didn't hear about it. And myself, I've tried to teach mine, but they are not super interested, so I failed. And I've been having more fun building this than actually teaching them.
Is there, are your kids old enough for like Minecraft or the other like game ones that nerds kids often get exposed to? I don't even know what, or something, Roblox?
Roblox, yeah. So that one, it seems interesting, right? Because I think you can create your own stuff with Lua. But mine are too young still for this, and they actually shouldn't be playing, but they are really playing. But yeah, that one I would like to learn a little bit more, just because it seems interesting. The Roblox thing, how to code your own stuff. But yeah, I just don't have time. I tried, what is it? Scratch Junior, that just is pretty cool. It's a bit frustrating to have to track so many things to get even the basics running, but you can make very cool stuff. Yeah, you can visually work more. If you go to the blog, it's my site, but there is kind of like an entry for every of the releases I built and the motivation behind each of them. So you can read there. Okay.
Cool. Yeah, thank you so much. This was awesome. Thank you.
Welcome.
I'm going to stop recording now, and since this time so far there were no weirdos who showed up, we'll do what we used to do. Just leave, like, I don't know, the last 10 minutes or something if anyone just wants to chat in general. I see that Caleb is now no longer in a trailer. You're now in a house, so that's interesting.
Yeah, we for those of you